Good morning. And in this session, I'm gonna make a small revision for exam one tomorrow. And exam one includes only chapter two, and that's motion in one dimension. This includes horizontal motion, free fall, and motion diagrams. Okay. So let's start with the horizontal motion exercise. We will do it together here. So there is a motorcycle that starts from rest. This V initial is equal to 0. I put all the information on the drawing. Actually, this exercise is on page 72 in your booklet. Okay, page 72, problem number 2. You can read the proper problem, but we put all the information on the drawing. So the initial is 0. It started from rest. It moved with an acceleration of 2.6 meters per second square. And it gives us that OA, which is the distance between O and A, delta x1 is 120 meters. As for segment 2, delta t is 10 seconds to go from A to B. It took the motorcycle 10 seconds, and it was moving with a constant speed. If it tells me it's moving with a constant speed, immediately what do I know? I know that A equal to 0. Okay, so let's start. Part A. Part A. Find the time needed for the motorcycle to move from point O to point A. So what information do I have here? I have the initial. I have acceleration. I have delta x, and it's asking for delta t. Okay, so which equation among these four has all these information? The initial, acceleration, delta x, and delta t. This is equation number 1. So using equation number 1, what do I get? Delta x is equal to the initial, which is 0. So the first term is 0 plus half. So half A, how much is A? It's 2.6 times delta t squared. Okay, instead of delta x, I will put its value, it's 120. Delta t squared. Okay. So from here, I get delta t from O to A. Part B. Part A. Find the speed of the motorcycle at point A. So this is also from O to A, okay? And it needs the V at A. So again, I have the initial, I have acceleration, I have delta x, now I have delta t, and it's asking for the final. How much is the final? Okay, so which is the easiest equation here? It's the third equation, although I can use the second equation and the fourth equation as well. But using equation 3, it's the easiest. Using equation 3, V at A is equal to V at O, which is 0, plus A is 2.6 times delta T. We just got it from part A. Delta T from part A. Okay. Part C. Part C. Let's do it here. Part C. Find the distance traveled by the motorcycle when it moves from point A to point B. From point A to point B. What information do we have? Do we have the initial? Yes, it's VA. We have it from part B. Okay. What else do we have? we have acceleration is 0. So we have acceleration. We have delta t. Okay, we have delta t. Actually, we also have v final. We also have vb, which is v final. vb, it is v final. It's v final. And what is the question asking me for? Calculate delta x. Okay, calculate delta x. So I have the initial, I have acceleration, I have delta t. So let's see if the first equation I can use it. Delta x is equal to this. I have the initial, I have delta t, and I have the acceleration is 0. So I can use the first equation. So using first equation, delta x from a to b is equal to the initial, which is VA, times delta t, where delta t this time is this. Delta t is 10 seconds, and VA is VA from part B. Okay. So this is part C, and finally, part D, find the average speed of the motorcycle during the whole trip. Here we have to remember that V average is equal to total distance divided by total time. Okay, so let's see if we have total distance. Total distance equal to distance from O to A, from O to A, plus distance from A to B. Do we have these? Distance from O to A, it's given. Here it is. This is distance from O to A. Okay, and distance from A to B, it's here. We calculated it in part C. So we are done with total distance. Let's see total time. Total time, it's equal time from O to A plus time from A to B. And let's see if we have it. So time from O to A, we calculated it in part A. So we have it. Time from O to A, we calculated it in part A. Find the time needed for the motorcycle. This is it. And time from A to B, it's given. Time from A to B is given. So I just add these two, and then I divide total distance by total time, and I get my average. Okay. So notice here, I always had to do this analysis. Before I start solving the exercise, the question, I need to see what do I have given and what is missing. And everything I will find in these four equations. Let's take another exercise. Let's work together. So this is also at the end of the booklet, page 73, problem number 3. This is a motion diagram that has velocity on the y-axis and time on the x-axis. And it's just saying, and I did not copy it all, it's just saying that from O to A, it's moving in one way, from A to B in a different way, from B to C in a third different way. And it's all shown on the graph. Assuming that at T0, x equal to 0, this information is important because it tells me that the displacement and the position will be the same. Just in case it asks me for the position. Now, let's do it part by part together. Find the acceleration of the particle during stage 1. So we look at stage 1. We look at stage 1. It's here. Okay. So since the velocity is changing, so the velocity is changing in a straight line, okay, with a slope, straight line with a slope not equal to 0, slope with a straight line, not horizontal. If it is horizontal, like in the case AB, then the acceleration is 0 because the speed is not changing. But velocity is changing from O to A, velocity is changing in a straight line, not horizontal. Implies acceleration is equal to the slope of the straight line. To get the slope, I need 2 points. So let's take the 2 points, 0, 0, for example, because this will make my life easier, 0, 0, and I need 2 points, 0, 0, and the second easy point is 10, 20, right? 10, 20. Now, let's do the calculation. So acceleration will be equal to y2 minus v2 minus v1 over, which is delta x, delta v over delta t, sorry. That is 20 minus 0 divided by, so it is v final minus v initial divided by t final minus t initial, which is 10 minus 0. So this gives me 20 divided by 10, 2 meters per second squared. We got A, let's call it A1. Find the displacement of the particle during stage 1. Okay, so this was part A. Now part B. Find the displacement of the particle during stage 1. So what information do I have? I have the initial. How much is the initial from the graph? From the graph, how much is the initial? It's 0. What else do I have? From the graph, from O to A, what do I have? I have the final. So I have the initial, I have the final from the graph, I have acceleration calculated in part A. Okay. What else do I have? Do I have delta t? Yes. From graph, it's equal 10 seconds. Okay. And the question is asking me to calculate delta x. So I have the initial, the final, acceleration, delta t. What would you like to use to get delta x? I can use the first one, the second one, or the last one. So using equation 4, for example, can calculate delta x from O to A. This is part B. Part C. Part C. Find the displacement of the particle during stage 2. So now I have stage 2. Stage 2 from A to B. So it's asking me for the displacement of the particle during this stage. Here I have to remember velocity is constant. It's constant. You either remember that when the velocity is constant, velocity equal delta x over delta t. You either remember this, or you just use the first equation where acceleration is 0. Okay, because here if we put acceleration is 0, acceleration is 0, I will have the same equation. Delta x will be the initial delta t. So from here implies delta x is equal v times delta t. And this is between what and what? Again, part C, between A to B. So how much is V at A? It is 20. So V will be 20 times delta T, where equal 20, and delta T equal 30 minus 10, that's 20 seconds. From graph, both from graph. Okay. That's part C. Find the acceleration of the particle during stage 3 from B to C. So I will do exactly what I did in part 1. I will choose the 2 points. So let's do it here, part B. So what information do I have? I have the initial, which is VB from graph, and I have delta T. Okay. Here, the other way to do it is to say that V is changing exactly the same way in a straight line, not horizontal. Okay. So A is equal to the slope. And I need to choose 2 points. So let's choose 30, 20. We need 2 points, 30, 20, and 40, 0. 40, 0. So it is this point. I took this point and this point. Okay. 30, 20, and 40, 0. So A will be V2 minus V1 divided by T2 minus T1, that is 0 minus 20 divided by 40 minus 30, and this gives me minus 20 divided by 10, which is minus 2 meters per second square. Minus 2. Am I expecting the minus? Yes, because the speed is decreasing. The speed is decreasing. Is there another way to do the A without doing this slope thing? Yes, there is actually. I just use equation number 3. I use equation number 3 over here. So another way, let's put it in different color. Another way to get acceleration is to use equation number 3 for both part A and part B. Okay, let's see if we use equation 3. So equation 3, V final, like for example in part D, V final is 40 equal. V initial is 20, okay, plus A multiplied by delta T is 10. So how much will be A? I have to get the 20 to the other side, 20 to the other side. Sorry, here V final is 0, okay? V final is 0 because this is the velocity. So V final, that is V of C, is 0. It's equal to V of B, which is 20, plus A times 10. If we solve this, we will get minus 20 equal 10A implies A equal -2. So I got the same answer, okay? So I can either solve it using the slope, or I use it, or I do it using equation 3. This is part D. Find the total displacement of the particle during the whole trip from O to C. Displacement in stage 1, I already have it. Where is it? It's part B. So in part B, I have displacement during stage 1. Part C, I have displacement in stage 2. I just have to calculate displacement during B to C, and I will do it exactly how I did part B. So part E, similar to part B. What information do I have? I have the initial, I have the final, I have acceleration. I calculated it in the previous part. I have delta T. So use any equation. For example, use the first equation, the initial delta T plus half A delta T squared. Use equation 1 or 4 or 2. Any one of them can solve this problem. So I will get the displacement, and then total displacement will just be the sum of all these displacements. Okay. Is there another way to do it? Yes. I don't know if you still remember. There is another way, which is the area under the graph. It's the area under the graph. In this case, area of a triangle is length times width divided by 2. So it will be 10 times 20 divided by 2, plus area of the rectangle, which is length times width. So it will be 20 times 20, plus area of this triangle, which is again length times width divided by 2. So it's 10 times 20 divided by 2. So let me put it here. Another way for the total displacement area Okay, let's let's erase a little bit. So displacement is equal to the total displacement. So one way, as we said, we just sum up what we got from part B, part C, plus we calculate in part E the displacement, and then we sum them up. This is one way. Or we say it is area under the graph. And this is equal area of triangle, plus area of rectangle plus area of triangle. Let's call them triangle 1 and triangle 2. So this is 1, this is 2. Okay. And how much is this? This is equal to 10 times 20 divided by 2. This is area of a triangle. Area of the rectangle is length times width. So it is 20 times 20, length times width. Area of the last triangle is length times width divided by 2. So it's 10 times 20 divided by 2. Just calculate it and compare it to the case where we have where we sum up the three displacements. Okay, let's move on. This is one of the exercises that was in your assignment. I realized that many of you didn't know how to solve it. I think here let's try to do it together. So this is a free fall experiment. This is a free fall problem. So the first thing we have to remember is that acceleration is equal minus 10 meter per second square. So in all these equations, I already have the acceleration. In all these equations, I already have the acceleration, okay? Now, two balls are thrown vertically from the same height, at the same moment, t equal to 0, t equal to 0. Let's call this point here O, where let's say x of O is equal to 0. Okay, it's also telling me that they were thrown with the same speed, V0 equal 2 meters per second. So V0 is equal 2 meters per second. This is as a speed. Okay. The black and white balls are launched in opposite directions. What does this mean? This means that V for the white, so let's say V0 white, it's V0 white, it's equal plus 20 meters per second. Okay. However, V0 black equal minus 20 meters per second. Okay. Okay. Now, just after the black ball hits the ground, what is the time needed for the white ball to reach the ground? In fact, all you have to do here is to calculate how long it takes the black ball to reach the ground. Then you calculate how long it takes the white ball to reach the ground. Then you subtract. Okay? Because this will be just after the black ball hits the ground. What is the time needed for the white ball to reach the ground? Notice that the black ball will arrive before the white ball. So the black ball, it will take, let's say, 1 minute to reach the ground. Okay? The white ball, during this time, it will be going up, 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 and down, down, down. So after 1 minute, that is the 1 minute the black ball takes to reach the ground. After this 1 minute, how long extra does the white ball needs to reach the ground? So it will be the total time the white ball needs to reach the ground minus this 1 minute or whatever time we will get. Okay, so let's start with how long it takes the ball to reach the ground. So we will start with the black ball. So start with black ball. What information do I have? I have the initial. It's minus 20, right? Meter per second. What else do I have? I have the acceleration, minus 10 meters per second square. What else do I have? I have delta x, which is minus 20. It's going from O to B. That's what B here. X of B is equal minus 20 because it's in the opposite direction of the x-axis. Okay, so I have the initial, I have A, I have delta X. Can I calculate delta T? Yes, one way to do it is to use the first equation. And for this, you have to learn how to use your calculator in quadratic form. The other way I do it, is that I calculate. So if I don't know how to use scientific calculator to solve quadratic equations, then the way I will do it, because notice, if I come to the first equation, delta x I have, the initial I have, acceleration I have, but here I have delta t and here I have delta t squared. So this is a quadratic equation that I don't know how to solve. If you don't know how to solve it using the scientific calculator, then it will be problematic. So the way I do it is I calculate V final, that is VB, using equation 2. Okay, then plug it in equation 3. Okay, so what does equation 2? Equation 2 is what? Equation 2 is VB squared, let's put square, just give me a second, this way. VB squared is equal to V initial square, V initial square plus 2A delta X. Okay, I have the initial. Yes, I have acceleration. Yes, I have delta X. Yes, from here I will get VB. VB, if you do the calculation, you will get VB, equal minus, it will be plus or minus 20. Just a if you do the calculation here, you will get VB is equal plus or minus around 20. So it will be 20.0 something. So it will be 20. We choose the minus because it's going downward. Okay, so it is minus 20 meters per second. So I leave it for you to do this calculation. This is for the black ball. Now I do the same for the white ball. So let's do it in a different color. So for the white, before I start with the white ball, once I calculate VB, now I can use equation 3. VB equal VO minus 10 delta T, and from here you get delta T for black ball 1.8 seconds. I'm giving you the answers so as you can check them yourself. Okay, now I do the same for the white ball. For white ball, I will do the same. So I have the initial, it's equal 20 meters per second. I have acceleration minus 10 meters per second square. I have delta X. It's also from where it is launched toward where it reached. So it's also from O to B, which is minus 20 meters. So I have the same thing. And I will use exactly the same tactic. So first I will get VB it will be, if you do the calculation, you will get V final to be, let me check because I have the answer here. It is also minus 20 meter per second. Okay, and then I plug it in equation 3. So you will say minus 20 equal to plus 20 this time, plus 20 minus 10 times delta. Okay, and you will get delta T for white pole to be equal to 2.2 seconds. So time difference equal 2.2 minus 1.8, because that's what the question is asking you for. The time difference between the black and the white. This will be 0.4 seconds. Okay, so this was not a very straightforward exercise. You had to think a little bit of what it is asking you for, and your life will get easier if you learn how to use the scientific calculator, because to solve quadratic equations, because then you don't have to get V final and then from V final to get delta T. Okay, so this is revision for the exam. I will see you soon in the live session. I will take questions if you have questions, and if you don't have questions, I will choose some of the exercises from the assignment and we do it together. Okay, so bye-bye for now.